Hello, hello. Testing audio. Let me see. Hello. Is the audio working here? Okay, audio is working. So I'm gonna start here. Okay, guys. So the idea here is to give just really a very quick sneak peek on some of the new stuff for 124, and you guys can ask me some quick questions about these things. So I plan to show about three things today. So one is like filters, which is a long thing that people have been waiting for a long time. Second one is um, some of the new 3D physics things, especially terrains and static meshes, and how that will go with physics, and also the new kinematic character controller 3D. That's it. I'm not going to show now the new interpolator method. I can record a quick video about that yesterday, later because it's on different branch and I don't want to waste any time um, with stuff that I have to switch branches here, etc. So going real quick to filters. So you know that you've it has always been possible to do so it's always possible to go through entity types by using get all, let's say, whatever is your entity type name. And we also had similarly get all and then for any component generated, but this was very limited because you could only filter by one component at a time. So people always wanted to have filters, and it's been discussed in the announcement channel about how to come with an interesting syntax for specifying filters, and we ended up with this. So essentially, you use the filter keyword in a qtn file, and you give it a name. And essentially, you can have as many has clauses as you need to say, hey, I want this guy to filter entities that have both character controller 3D and transform 3D. You can also have a not clause saying, and also things that, and definitely they cannot have a certain component. And the any clause is interesting. It will have to have one of these, but it's exclusive, so one is going to be null, the other not. So it gives you a flexible API to get different types of entities as well. But normally the has and not was already interesting to filter most of the entity types you have. And so I'm going to quickly show how this translates into a system. How do you use this from a system perspective? But I'd like also to mention that this has also an excellent performance. So prior to 124, get all entities and get all certain component, etc., would traverse all entities lots, even if they were not used. For 124, we came up with a completely new code-generated create destroy mechanism based on a double linked list in the metadata internally on the entities. It doesn't change the APIs for create and destroy, but it guarantees you have O1 and performance, O1 complexity on, gives O1 complexity on create destroy and guaranteed ON traversal, where N is the number of active. Yes, I'm talking about the performance right now. So filters in particular, they are also code generated. So essentially this, when you define a filter, the code generator knows which entity types will, let's say, comply with this filter, will match this filter, and essentially it generates a concatenated iterator that has ON performance guaranteed over the active instances of each one of the entity types. So say if this filter matches two different entity types, and one of them has two instances and another one has three instances, this is guaranteed to go over the five of them, and it only touches those five entity slots. It never touches the other ones because it concatenates the double linked lists internally on the generated code. So it's very, very efficient. So it's even much more efficient than the original limited filters we had. So let me show you the API for it. So it's much more similar to get all entity types than the original get all components that gave you a buffer, or that gave you that buffer that you had to traverse differently. So filters, they exist into the frame as a separate object called filters. And here you see that we have pre-built filters that behave like the original get all of a certain component. But you also have any custom filter you defined, and this is the filter we defined in that file, like my characters. So you just call this method as like you would call like get all for a certain entity type, and this gives you an iterator with exactly the same API as the get all certain entity type iterator. So you just have the next method, and an interesting thing about filters is that it will give you not only the pointer to the entity, but because you have the has, not, and any clauses, you also have cached references to the pointers of each one of the has components that you defined. So you don't have to cast that from the entity. This is the exact entity star. So because this can match several different entity types, we don't give you exactly the entity. You get that from the entity type you have here. But we already give you the components you were interested in already as a cached reference. So you see here, you can see here my characters has direct reference to character controller, to transform 3D, because they were both predefined as a has clause, each one of them. The any clause is interesting. It's specifically set as any in the iterator, and it gives you also a pointer, but it can be null, because any, it's not guaranteed that you have that particular one. Like it has to have to comply with one of them, but not all of them. So it will give you the pointer to both, and you have to check for null in this case. And that's essentially it. Pretty good performance, and much more flexible entity filtering with this. So if you guys have any question about filters, I think that's pretty much it. So I might just also move on to new 3D physics. I'm gonna build everything here and see if you guys have any questions. So let's see. So this is our test scene for 3D physics, and you can see right away that, yay, we finally have a Unity terrain here, and the green triangles and the red normals are the FP versions baked from the Unity 3D terrain. So just a quick thing here. Essentially, you can use a Unity terrain and set it to whatever values you need. And there is a new, let's say, Unity script called Terrain Collider Data, which is the Quantum one. Maybe I will still rename this, but essentially this can bake the terrain data from Unity into the corresponding Quantum FP Vector 3 based terrain. It actually saves the height map, and the triangles are generated on load. But not only terrains, you can also have arbitrary meshes. So this is a mesh I created on any 3D modeling program. It's triangle based, so it needs to be triangle based, of course. And then you can just drag the mesh into the scene. And if you add this static mesh collider 3D, which is similar to box and sphere collider, but just for meshes, you can have the expected material, asset, and trigger parameters, but it will actually bake the triangles into Quantum and also pre-compute the normals and all the things. And when you bake the map now, then I was answering the question here about the component types in the any and has clauses on filters. No, really, that's really about the number of component types you have. You're limited to 64. There was also a bug into a flag that was being used as a 32-bit. So in practice, older versions of the SDK were limited to 32 component types, but it's actually 64. So we're fixing that. So by having the meshes here, we now have, so you know that we already had box and sphere colliders, and they work nicely against the terrain and the meshes. And another thing we fixed because it was missing is that you now can have relative points. So I'm raycasting here the box and adding a force to a relative point in the box, so you see it rotating. But so this is just so these meshes, they are stored in a separate broad phase data structure that we're going to evolve it eventually to a BSP triangle struct. And we're also revamping all the whole broad phase data structures, but that's going to come on 1.3. So one clarification here about 1.2.4. So 1.2.4 is going to bring a few important things for the 3D physics. First is mesh and terrain colliders, triangles, so you can have much more complex levels and express a lot more things. And it will also come with not on the first beta, but eventually in one of the release candidates, we're going to have the physics, the 3D physics fully inlined. So we'll be able to start measuring performance on the 3D physics, because so far all the code on the 3D physics is not inlined. And we know from our experience on the 2D physics that we can get a lot of speed up by inlining the full code. So this will come into 1.2.4 RC something, probably RC 1 or 2, not too long, but not on the first beta that we're planning to release very soon. The beta is going to come with all these new features, but the performance itself is going to be better on one of the RCs. But the other performance improvement is going to come with 1.3, which is when we're going to completely change the broad phase data structures. But yeah, it's already going to be much faster with the inlining, and then it will only get better and scale even better with the new broad phase data structures. So that's about the new mesh colliders for static level design. And we also found a few things that were important. So we fixed the sphere raycast that had a nasty numerical accuracy bug. So we came up with a new method that actually doesn't suffer from that. And it's working nicely. That will also come with 1.2.4. But there's one more thing that's worth mentioning, is that this is also another thing that people have been asking for since a long time ago. So we had hard-coded friction and restitution combined functions, so they were not great. And now you can essentially choose from the material what is the combined function you want. So, for example, legacy is the current code that you guys have on 1 to 3, but you can now choose from max, mean, average, and multiply, both for friction and for restitution combined. One important question to answer here is which one is preferred when you have two bodies colliding and they have different restitution combined functions. So there is a precedence here that's going to be in the documentation. I'll even have to check the code here to see. It's the maximum one between them based on the enum values on them, but this is still a bit open. So if you guys want to give an opinion on which one should be the let's say the precedence order of these, so they can be resolved fine when the two materials have different combined functions. But that's it. This option is already implemented and available, and this comes both on 2D and 3D. So what else is standard on the new physics? Not a lot, except for this guy here. So we finally took the time to implement a character controller. So the idea is to have something that's more than the Unity character controller that essentially gives you a basic movement code. This is on, let's say, its first stage of development. I'll show you a few of the features that it has. So this sphere here is actually a character controller. So the interesting thing about character controllers is that they move against the 3D physics data, both statics and dynamic objects block the character controller from moving. So you see here that I cannot go through this dynamic object, although it's completely dynamic. I can remove it out of the way here. There will be an option for you to make the character controller move the dynamics as well. But you see that I'm going through the terrain as well. You can see real close here. I'll in a few minutes show the configuration files, but it handles steps just fine. And it also handles slopes. So this is a non-very steep slope, so you can actually go through it. But if we get here, we're gonna slide down because this is too hard slope and you cannot go through it. So you cannot go up. So you see this is also too high of a step, so you cannot go through. But if you go through here, I think the slope is enough. Yeah, you can come here. So this is a kinematic character controller with a custom implementation we came up with by discussing with a few fellow developers. It already handles elevators and these like moving platforms, like elevators, fine. But because it will come also with callbacks for the collisions you touch, both statics and dynamics, you can also react to, let's say, bridges and things like that, or maybe even apply forces to dynamics yourself when you react to a callback directly on the character controller. But the most important thing, to me at least, in the character controller is its flexibility. So let me show you how it is on the QTN file, because it's a very interesting thing to show. So okay, so this is my character controller enabled entity. You see that it requires a transform 3D. It actually does not require the transform 3D itself. You see that from the API we just pass in a position. And it is a character controller 3D, but you see that it is not a dynamic body or a kinematic body at all. It's a completely separate thing that uses a single shape overlap to a single sphere shape overlap with an offset to check for the movement. And why is this so important? Because you can combine it. So this guy here can be combined with 2D or 3D transform, and also with or without dynamic, let's say a kinematic body. So say if you want your character to have a body that can be, for example, a box, so you can shoot against the character, add a dynamic body to it, with the shape you need. The character controller is a completely separate thing with a different offset, with a different radius that just works for the movement. So you cannot raycast against the character controller. You raycast against the body if there is one. And because this is completely agnostic to whereas you're using either 3D or 2D physics, you can have the character controller working against a 3D environment, but actually use the 2.5D physics for performance on other stuff. So it's really up to you how to mix and match these things. So I really liked the result here. So of course, this version of the character controller moves against the static and dynamic objects on the 3D physics engine, but it doesn't require everything to be on 3D and 2D, and even your character controller itself transform doesn't have to be 3D. So let me show you the API in here. So it's still lacking the init method and so on, but the most important one for you is this. So it has the move method. And the move method requires you to pass in a 3D position, and so you don't have to actually have a transform 3D. It just means you have to pass in a 3D position, but you can generate this based on whatever data and however you actually position this guy. And a direction, which is the velocity, which means direction and velocity and speed you want to move. And you have to, for now, I'm trying to see if we can solve this in a different way, maybe just passing frame, because I require the 3D scene and the delta time to actually complete stuff. So I think I'll end up just passing in the frame. But what it does is you try to move with velocity, and it gives you back the actual vector of the movement you are allowed to do, so you do not penetrate other bodies. So it resolves that. But it also has a completely optional jump feature that you can either pass in the impulse you want for the jump, which is going to be opposite to gravity, or you just use the one that comes from the character controller config, which is what I'm going to show now. So the character controller config, so Physics Engine has a default one, but you can actually use your character controller with a different config. Comes with a few things. So first, the offset. This means that the round sphere that actually represents something around, let's say, the feet of your character, or you can make it very big and actually represent the whole character if you want to. This it requires an offset because of that. So essentially, say you have a big collider for the rays and stuff against your character, but the character controller sphere is just around your feet. So your character's feet. So in that case, you have to use an offset. So, but of course, this is optional. It can be 0. It has a few important things. The base radius, that means that's going to give you the limits of where it actually stops penetrating. But it also allows a slightly flexible penetration to smooth out when you penetrate a little bit. And after you pass this max penetration, it can hard fix to you go to the correct radius. The extent is important because it's the radius that is used to actually check the collisions around you. So you can experiment with different values here. It lets you configure how many contacts you want to be able to compute. It works fine with one contact if you want to. So even with one contact, it works fine for slopes and everything, etc. So you see here that it works fine. And this is going to give you the best possible performance. But normally it works best with, it's going to be smoother under hard situations if you have 2 or 3 max contacts. The performance is not going to be that much different. But yeah, one is going to be, of course, the fastest one possible. Controlled fall, it's air control. I mean, Frederick fixed me. I'm going to change the name of it. This means that you have control over free falls and jumps, so you can move the character around while jumping. If you disable this, essentially, you cannot control the direction of the character when you're jumping. It just jumps vertically. Then standard things like acceleration, base jump impulse if you're not passing it that. A few of these things are going to be also cached in the character, so you can change on the fly without having to switch the config. So these max speeds, maybe even slope angle, and other base jump is not necessary because you can pass it as a parameter when you call jump, but some of the others are going to be cached into the entity component itself, so you can change them on the fly if needed. So so this is the basic thing that will work well for most of the things. You see that jump is completely optional. You don't have to use it. You can control, because essentially this is a suggestion of how to move. You can actually move any way you want, and for example, control the jumps yourself. We know that character controllers are very, very tricky things. You can spend hundreds and hundreds of even thousands of lines of code to have this right. So we're trying to come up with an API that's as flexible as possible, that does not, let's say, restrict you into how to use it. So I showed you the two basic functions, so move. So this move code here will use all those parameters, and some of them are going to be cached. But the jump is completely optional, and will also offer a simple move function that's similar to the one on Unity. Just moves you on the scene and tells you how much you can move without considering any jump and any other complex stuff. So we'll see how to expose that as well. So I'll wait a few more minutes if you guys have questions, but this is the sneak peek I'd like to give you guys about these new features coming in 1.2.4. So yeah, I'll still be online for a few minutes because of the delay of the call. And that's it. And later I'm going to share the link for anybody who could not or did not want to see the live streaming. And thanks for the guys who actually were watching live and the questions, right? So it's been nice. Let's see. Okay, I think it's been... Okay, so I'm going to stop here. You guys can still ask any questions on Discord. So thank you very much, and maybe see you next time. Let's see.